So let's look at the graphs of natural logarithm functions. Here's one of the problems that we can discuss in the verbal section. The inverse of every logarithmic function is an exponential function and vice versa. What does this tell us about the relationship between the coordinates of the points and the graphs of each? Well, notice that the orange one is the logarithmic function log base 2, and the blue one is an exponential function base 2. And you can see that they mirror each other around the line y equals x, like all inverses are supposed to do. So what you can tell is that when the log has the point 1, 0, the exponential has the point 0, 1, and where it has 2, 1, 2, the log has where the logarithm has 2, 1, the exponential has 1, 2. So you can see that the points are just switching places, just like inverses are supposed to do. What types of translations, if any, affect the range of a logarithmic function? Well, like any translation, the range is affected by what you do to the outside. So if you have here the gray one is the logarithm, then if you multiply by 2, it stretches it away from the axis, leaving the point where it crosses an anchor. If you multiply it by half, it squeezes it, so that's the purple one. If you multiply it by a negative, then it flips it over the axis. So just like any translation, the same. But one thing that's kind of unique is that if you change the base, remember natural log is base e. If I take the log of the reciprocal of the base, you get the same as the flipping it around the axis, because you notice that the red one and the black dotted one are the same exact function. What types of translations, if any, affect the domain of a logarithmic function? Well, same as it did before we did translations. If you multiply by a negative, it flips it around. So when you're looking at the graphs, you tend to look for the horizontal or the vertical asymptote so that you can see where things have moved. So when you multiply by negative, it flips around 0, because that's the asymptote of the log, which is in gray. And then if you subtract, it moves it to the right. If you were to add it inside the function, it moves it to the left, just like any translation. Here's one where it actually does both, right? What types, if any, affect the range and what affect the domain? Well, if I take natural log times 2x, I get what it was supposed to do is it's supposed to squeeze it towards the y-axis. But if I take natural log of x and add the natural log of 2, notice that it moves it up and it moves it right on top of it. So these two are actually the same function. So we're getting a hint of one of the properties, that if you could multiply two things inside of a logarithm, that it's the same as adding those two pieces that are being multiplied together, the natural logs of them, that is. All right, so here's a problem. You just have to match it up. So what do you look for when you try to do these matching things? Well, the one thing we know is that the log, whatever base of the value that matches the base, is equal to 1. So if I take and I look at 1 here and I go across, the first one I hit will be the smallest number. So that would be, you could actually tell that that's the 2. So you go down below and that would be 28. If I keep going across, this is some point that's almost 3, which, let's say 2.7, so that would be the natural log. If I keep going across, then of course this one's going to hit this one next, so that's the next biggest number, which I guess would be 5. And then D would be the next biggest, which would be 10, and then the last one would be E, because that's the next biggest one. Here, again, you can use 1, right, and get a sense of what it is. So if I take go from 1 and I move across, I hit 2, so that's the log of 2, which is 32. Now here, if I go straight across at 1, I hit things that are less than 1. So now you can see that the base would be fraction, which these two are. So now the first one I hit, that's the smaller fraction than the bigger fraction because it's closer to 1. So the smaller fraction is 1/3, that would be B. And then the 3/4, which is closer to 1, that would be 33.